Okay, the last example for implicit differentiation, we're going to find the slope of 3 times x squared plus y squared, so the quantity squared, equal to 100xy at the point 3, 1. As you can see, this looks like it'd be a mess to try to solve for y and put it in explicit form. So instead, we're going to put it, we're going to solve it implicitly. And I said this might take a while, and it might get a little messy. All right, so we're going to determine the slope, which means we're going to take the derivative. Okay, so let's take the derivative. When we take the derivative, looks like we are going to have to do the chain rule in here. We have an inside function and we have an outside. All right, so we're going to have to do the chain rule. I'll take the derivative of the outside, so we'll bring my 2 down, and we'll decrease the power by 1, so I'll have 6 times x squared plus y squared. And then I need to take that times the derivative of the inside, because that's what the chain rule says. All right. Okay. Well, I'm taking the derivative with respect to x. So then I can take the derivative of x squared, and that just becomes 2x plus, now I need to take the derivative of y squared with respect to x. So the chain rule says we need to take the derivative with respect to y and take it times the derivative with respect to x. So dy dx. So my derivative on my left side is okay. All right. Equals, now I need to take the derivative on the right side. Well, it looks like we have 2 functions multiplied by each other. We have 100xy. xy is multiplied by each other, so we have to do the product rule. All right. So on my right side, I'm going to do the product rule. The product rule says I do the derivative of the first one. So I'm going to say 100 times, derivative of the first one is, I'm just going to say is x. So the derivative of x is just 1. So 100 times 1 times y. So my derivative of the first one times the second one, plus the derivative of my second one. So now you take the derivative of y. So I'm going to leave 100x, and I'm going to take the derivative of y, which is just 1. But we're taking it with respect to x, so we need to do the chain rule and say, okay, so the derivative of y is dy dx. Okay, we're good so far. Now we need to do a little simplifying in order for us to solve for dy dx, because we're solving for the derivative dy dx. What I'm going to do is I'm going to leave my 6 outside, and I'm going to FOIL this left side out here. So I'm going to take x squared times 2x. I'm going to get 2x cubed. All right, then I'm going to take x squared times 2y dy dx. So I'm going to get plus 2x squared y dy dx. All right, now I'm going to do my y functions. All right, so I'm going to get y squared times 2x. So I'm going to get 2y squared x. And then I'm going to get plus 2y cubed dy dx. Alright, so now I have it all foiled out on the left side. I can't really do too much on the right side, I guess. So I'm just going to leave it 100y plus 100x dy dx. Alright, back in the last video, we learned that our steps is to isolate the dy dx. Move everything on dy dx to the left side, everything that doesn't have dy dx to the right side. Alright, so we're going to try to do that here. I'm going to go ahead and distribute by 6, so I don't have to deal with that 6 on the outside anymore. So I'm left over. Then after I distribute, I have 12x cubed plus 12x squared y dy dx plus 12y squared x plus 12y cubed dy dx still equals 100y plus 100 x dy dx. Alright, now I'm going to isolate, so I'm going to get all of my dy dx's. Any term that has a dy dx on my left side, any term that does not have a dy dx on the right side. Alright, so I'm going to keep, looks like I'm going to keep this term, and I'm going to keep this term, and I'm going to move this term over to the left. Alright, so I'm going to keep I didn't need that plus, sorry. I'm going to keep my 12x squared y dy dx plus 12y cubed dy dx. And I'm going to move over my 100x dy dx. And then on my right side, I'm going to move this stuff in blue over. All right, and I'm going to keep this 100y. So I have a 100y minus 12x cubed minus 12y squared x. I think I have everything there. All right, now our directions for taking implicit differentiation says I'm going to factor out dy dx. So I'm going to factor out dy dx. And what I have left over on the left side then is I have 12x squared y plus 12y cubed minus 100x. And that's going to equal, still nothing changes on my right side, 100 minus 12x cubed minus 12y squared x. All right, now I need to get dy dx by itself. So I'm going to divide the right side by what's in here. All right, so my dy dx equals 100 y minus 12x cubed minus 12y squared x all over 12x squared y plus 12y cubed minus 100x. All right, to make that a little cleaner, I think I can take a 4 out of every single term, I believe. Yeah, we can take a 4 out of everything. If I take a 4 out of everything, I'll be left with 25y minus 3x cubed minus 12. We're starting at 12. We're taking a 4 out of everything. Minus 3y squared x all over 3x squared y plus 3y cubed minus 25x. All right. So I think I've simplified that about as far as I can go. I don't think there's anything I can pull out more of that. So to go back to the actual question, they want us to figure out the slope at the point 3,1. So now all that's left over now is I just need to plug 1 in for y and 3 in for x. And we'll get our answer. So when I plug 1 in for y and 3 in for x, I'll have 25 times 1 minus 3 excuse me, times 3 times, let's see, 3 cubed minus 3 times 1 squared times 3 all over 3 times 3 squared times 1 plus 3 times 1 cubed minus 25 times 3. And when we figure that out, looks like I'm going to have 25. I have a space to write here. Looks like I'll have 25 minus 3 cubed is 27 times 3 is 81. Minus 9. 3 times 1 squared, which is 1 times 3 is 9. All right, all over. Looks like I have 3 times 3 squared. 3 squared is 9 times 3 is 27 on the bottom. Plus 3 minus 75. 3 times 25 is 75. So it looks like on top, all right, so negative 81 minus or plus a negative 9 is 90. 90 minus 25 is 65. Yep, 65. And then on the bottom, looks like I'm at 45. A negative 45, by the way. So I have positive 30 minus 75 is a negative 45. And I can reduce that. I can take a 5 out of both of those. And my answer then, finally, my answer is going to be, when I reduce this, negative 65 over 45 is going to be negative 13 over 9. Sorry about that, over 9. Negative 13 over 9 is the answer. Hey, that was messy, but it involved a lot of stuff that we've been doing in the past, product rule, chain rule, and implicit differentiation. So I thought I'd do a hard one for you, and I hope that helped.